Dear students, today we will start the new chapter, that is chemical equilibrium. In this chapter we will start with Gibbs free energy. By using the Gibbs free energy, we can predict the spontaneity of a process. As a chemist, we are interested in the reactions, whether it proceeds spontaneously or not, or backward reaction is fast or forward reaction when it will be fast. By using such Gibbs free energy, we can predict the spontaneity of reactions. Suppose, for explaining Gibbs free energy, how it's used in spontaneity of reaction, we have some examples. Suppose if a ball is falls from upside to the downside, okay, that process is a spontaneous process, correct? And if suppose we have a gas container is there and there is a compartment and gas compartment, and when we remove this compartment, then gas will be mixed. Okay, that process is also spontaneous process. Okay, already we have studied in second law, all the natural processes are the spontaneous processes. If suppose we have a hot water is there and the cooling of hot water, okay, that is hot water, its temperature is the high, the cooling of hot water is also a spontaneous process, correct? When we see the reactions such as the rusting of iron, it's spontaneous process. When there is humidity is there, oxygen is there, it's get rusted, and that is a spontaneous, it's a spontaneous reaction. All these things we discuss, we can predict whether it is spontaneous or not spontaneous by using the Gibbs free energy. The Gibbs free energy is given by the equation G is equal to H minus Ts. H is a enthalpy. H is an enthalpy quantity. S is a entropy. Okay, we introduce new concept, that is Gibbs free energy. We have known that what is meaning of enthalpy and what is meaning of entropy. Enthalpy is total heat content of a system. Enthalpy is called as the total heat content of a system. Suppose that is hot water is there and the cold water. Okay, after the hot water radiate energy or heat, it after some time it gets cool. That hot water has higher enthalpy because it is having high heat content. Okay, when temperature is increases, its heat content is increases, therefore it is having higher enthalpy than this system. Okay, both are systems, different system, because it radiate energy and it's converted to the other states. Okay, same system is converted to the other states. Right? Temperature is decreases, heat is decreases. Therefore, in this system, enthalpy is higher. Enthalpy is given by the formula H is equal to internal energy plus PV. The internal energy of a system is increases due to increase in rotational motion, increase in vibrational motion, increase in that is number of motions, molecules vibrating due to acquiring temperature, its due to position also internal energy is increases. Okay, in this case the potential energy is there. Okay, potential energy also increases the internal energy. That is, these all are the kinetics energy. That is okay, rotational, vibrational, and like that it increases the energy due to the heating of any substance. Okay, if suppose you take the ice has the less energy than the normal water. Therefore, normal water has the higher enthalpy than the ice because it is having the higher heat content. And then when you heating that water, its pressure is increases, volume is that also pressure volume type energy is also included along with the internal energy in enthalpy. Okay, therefore for understanding purpose you remember that if the potential energy increases, enthalpy increases, its temperature, its heat content is heating. If you heat that water, its heat content is increases. Okay, like that way you can remember heat content. If heat is higher for a system, then enthalpy for that system is higher. Remember that. Okay. Then by using we can predict the by using the Gibbs free energy we can predict the spontaneity of reaction. Suppose remember that Gibbs free energy as like entropy as like enthalpy, it's also a state function. Okay, state function means what? If suppose if x and y position is there, okay, when you move from x to y position, number of ways is there. Okay, number of ways you can move from x to the y. Okay, for x is the first situation of the first state and y is the second state. Remember that. But that state is obtained by the system by different ways. Okay, therefore, when we try to find out the difference between how much Gibbs energy or how many enthalpy change, how many entropy change, we can simply calculate it by the final states minus initial states. You can obtain easily values of change in that properties. Okay, therefore it not dependent upon the path followed by. Remember that. Therefore, that properties is a state functions. That, for example, enthalpy. If suppose you heated water, it's some enthalpy change. Okay. Other way, vibration is increased by heating or heating also vibration is by other way also. If you add the some or it's by rotation you increase its temperature, therefore it's vibrational, number of molecules collide with each other, its energy is okay. Such situation you obtain from heating also and other ways also. Then the change in enthalpy is we can give the by its difference. Okay, remember that in a state function the change in the enthalpy we can use by the subtraction of final by the subtraction of initial. Okay, like that way if you obtain the exact value of that functions, that is nothing but your state function. Okay, like that way gives free energy at any state we can predict and other state we can predict, and change in Gibbs free energy we can given by the final state minus initial state. That is the change in Gibbs energy is a state function as enthalpy and as like your entropy also. Therefore, change in free energy is given by change in enthalpy minus T delta S. Okay, that delta S is change in entropy, initial entropy, final entropy minus initial entropy. Okay, entropy, you remember that entropy is a mixed upness. Remember that mixed up. If there is mixed upness is there, entropy change in entropy is higher. In this case, there is a gas is compact in one country. When you remove mixed substance increases, it means the entropy is increases. Okay, in this case, if you heat, your system is heated, there boiling is takes place, there vibration of the molecules takes place. Therefore, there is a some mass is produces. Mass means mixed substance mass. Okay, like that. We can say explain the entropy. Okay, in if suppose in this case delta H is also state function, therefore change in Gibbs free energy delta H minus TdS use to find out the where reaction is the spontaneous or non-spontaneous. Okay, previously in first lecture for explaining entropy we have taken one example. If suppose like that molecules is there very okay, and it changes like that. Okay, it changes its position is like that. Okay, very good alignment you found in this case. When good alignment is there, then entropy is this. When there is disturbance is there, entropy is increased. Okay, disturbance, if you see the disturbance, it means the entropy. If there is water very if you put a stone on this water, there is a disturbance you produces. Okay, therefore previous water is less entropy, and after the disturbance there is a higher entropy. Okay, heating any substance, there is a molecules vibrate, therefore there is a disturbance is produces. When disturbance is produces, entropy is increases. Okay, like that how we use the delta G for the spontaneity of a reaction. If suppose for it is state function, for this if G one value for this ball, if it has a G1 value for this ball, it's having the G2 value. Okay, you found that we can define the Gibbs free energy like that in the mathematical formulation also. But Gibbs free energy is available energy to do the work. Okay, we can define available energy to do the work. Okay, in this case, if heat the water, it means due to absorbing energy, it has increases the that is its tendency to do the work. Okay, it does the work, radiate the energy, it's converted to the it does the work to the environment. Okay, therefore by losing the radiate or by radiating the energy. Okay, therefore when you look carefully this formula, you found that the G is equal to H. H is the heat content. Heat content means the heat content. It is responsible for to radiate energy. Okay, other way, heat is a we can call it as heat. Heat is there, therefore it has the energy. Okay, remember, therefore heat energy minus when you call temperature, and S is given by Q upon T. Therefore heat minus heat. Okay, when T is cancelled, heat minus heat, or heat other way, energy minus energy. Okay, other way, heat is there, their energy is there. Heat is there, energy is there. Therefore G is heat minus heat, energy minus energy. When you find out its units, you found that its unit should be the energy. Okay, that is energy. Energy is used for to do the work. Okay, in this case, you found that its potential energy is increased. Okay, that due to its position, potential energy is increased. Therefore, enthalpy is increases. And if you found that enthalpy is the increases, but there is no much more change in its S. Okay, entropy is not much, temperature is not changed. Therefore, by observing this equation, we can say that its potential energy, its H is increases, potential energy increases, its H is increases. Entropy remains same for this, temperature is remains. Okay, if ball is rolled, no change. You found there much more change in temperature or entropy is there. Okay, therefore, for this case, you can predict which is having higher gives free energy. Okay, for this ball it rolls. Okay, therefore for doing this work it is having some free energy and some work is done. If you roll this ball towards the uphill side, then it is not possible. It is not spontaneous. Some energies you have to give to this ball. Okay, therefore the energy of the final state is less because its potential energy decreases and is the higher. Okay, its final energy higher, energy is less. Okay, for its energy is decreased, potential energy decrease, and it is higher. Okay, when you find out the G2 minus G1, okay, that is nothing but delta G. Okay, change in free energy. Therefore G2 minus is less minus higher quantity. Therefore delta G is equal to minus quantity, negative. Remember that if delta, okay, by this way you can predict that that process is the spontaneous. From the upper side to the down inside, the process is the spontaneous. Therefore delta G change for this process is negative. Remember that when delta G is negative, the process is a spontaneous. Remember that delta G is the negative, the process should be spontaneous. Okay, if suppose you want to roll to ball this way, okay, so it is having then at the final state is like that. Therefore G2 minus G1. Okay, final state, if this ball you roll from this side to this, therefore our final state is G1 and initial state is G2. G1 is higher and initial state is G2, therefore positive value will be occur. Okay, therefore rolling of ball to the field side is a positive value, therefore it is non-spontaneous process. And okay, remember that two way we can discuss. Delta G is a negative, then reaction should be spontaneous, or any process should be spontaneous. Remember. Second, if delta G is the positive, it means it is a non-spontaneous process, is a non-spontaneous. If suppose delta G is equal to 0, it means reaction is at equilibrium. When delta G is the 0, then at that position your reaction is equilibrium. No further reactant is converted into product. When delta G is 0, when delta G is the negative, then reactant is converted into product and it will achieve the equilibrium position where delta G is equal to 0. Okay, remember that when G is there, G is the higher means, okay, for this is heated water, G is the higher. Okay, remember, every substance is trying to obtain the lower free energy. If system has the higher free energy, it is unstable system. If system has a lower free energy, it is a stable system. Okay, therefore if G is the less, then your system is the stable. Remember that. And if G is the higher, your system is the unstable. Okay, as a chemist we are interested in where the reaction is spontaneous or non-spontaneous. Okay, suppose we have an example, that is a regular example, that is A plus B gives C plus D and the D. Okay, A, B, C, D are okay. We have previously explained that is stoichiometric quantities are the moles. Okay, remember that are the moles. Okay, therefore for this equation or for this reaction, the change in free energy is given by the free energy of reactant minus free energy of a product. Okay, sorry, free energy of product minus free energy of reactant. Okay, remember that. Okay, therefore for your product C plus, that is your Gibbs free energy, then D GD, that is Gibbs free energy of the product, minus your reactant A minus, okay, plus, okay, that is the summation is there, BGB. Okay, therefore we can find out for any reaction the change in Gibbs free energy by subtracting of the Gibbs free energy of the product minus Gibbs free energy of reactant. Okay, therefore you can simply there is a summation of the first Gibbs free energy of the first reactant product, then the second reactant, there is summation is there. Okay, for that and so on, summation is there. For that we have there is a summation. Okay, that's mathematical form is the summation, and NP is your number of moles of the products, and Gm is the for the molar Gibbs free energy for the product minus summation of the Nr is the number of moles for the reactants, and molar Gibbs free energy for a reactant. Okay, molar Gibbs free energy for a reactant. Okay, product minus a reactant. Okay, like that way we can find out the delta G for a reaction. Okay, general equation we have found out. Okay, for the reaction. For standard, okay, what is meaning of standard Gibbs free energy? Okay, this is not standard free Gibbs free. Standard means at the standard situation. Standard situation means one pressure is the 1 bar and the temperature is you found 298 Kelvin. That is a standard situation. Okay, therefore standard Gibbs free energy, okay, you just replace the G0, that is G naught. Okay, G naught means the G not stand for the Gibbs free energy at the standard value. Okay, for the product minus summation of Nr Gibbs free energy and reactant at the standard state. Okay, therefore standard Gibbs free energy we can define as it is a difference of the standard free energy of product and standard free energy of reactant. Okay. Other way we can also define the standard free energy. Okay, other way is the change in Gibbs free energy when reactant is converted into product, when reactant is also in at the standard state and the product is also in a standard state. That is a definition is there. Another quantity we have for the simplification we have introduced, that is the NPGF0 product for the product minus NRGM G0FR. Okay, there is a formation of a G naught formation means the standard Gibbs free energy of formation. Okay, therefore it can be defined as the 1 molar substance is formed from the 1 mole substance of the reactant when both are present, both the reaction are present at the standard state. Gibbs free energy for the elements at the standard state consider as the 0. Remember that. Okay, therefore Gibbs free energy, if mathematically if you find out the Gibbs free energy standard, there is a delta H0 minus delta TdS. Okay, by using this equation, change in enthalpy, change in the entropy, by putting this value, you can find out the standard Gibbs free energy. By using the data of standard free energy, you can use the free energy of change in free energy of a reaction, and you can predict whether the reaction is the spontaneous or non-spontaneous. Okay, there is an exergonic process also and endergonic process. There is one process is the exergonic and second is the endergonic. Okay, it's like simply like the exothermic reaction, and it's simply like the endothermic reaction, exergonic reaction and endergonic reaction. If suppose from the you obtain from H2 and O2, you obtain the H2O. Okay, 1/2 O2 and twice H2O, you obtain the H2O. In this case, the Gibbs free energy G and the G is decreases. Okay, Gibbs free energy is decreases. That means the heat is lost from the reactants. Okay, therefore final Gibbs free energy less than the initial. Therefore, final G is equal to value delta G will be negative. If delta G value is the negative, that is called as the exergonic process. And in exergonic process, the product obtained is the thermodynamically stable than the reactor. Thermodynamic stable means what? It is having the stability than the your reactor. Thermodynamic stable means the product has the higher stable than the reactor. Okay, in this case, exergonic process delta G should be negative. Okay, remember that. In this case, product G value is less than the reactant. Okay, why this is happened? Because some free energy is the lost state. Due to that lost state, the energy is the last state, that is the exergonic process. That process is the exergonic. Endergonic process opposite to that. Okay, in this process, okay, endergonic process is opposite to that, and in this process you found that the delta G for this process is the positive, and the product is thermodynamically less stable than the reactor. Okay, by this way you can discriminate what is the exergonic process, what is the endergonic process. Okay, for this explaining the whether reaction is spontaneous, in which reaction considered as the exergonic, which reaction is considered as the endergonic. Okay, we explain in this lecture. Thank you very much.